Hello and welcome back to the lab. Today on the bench we have another suitcase, which probably means it's another tube tester, which might actually be correct. This is the last of the tube testers that I have in the queue at the moment, but this one I think is going to be kind of special. I have a data book that I printed out. We'll get into that here in a little bit. But first up, let's take a look at this. I'm going to move the camera up so you guys can take a look down. All right, a bit of a top-down view. Before I pop this open, once again, thanks for everybody joining us in the lab, and thank you to and a huge thank you to the patrons that help keep the lights on. So we actually have a Heathkit model TT-1, pardon the camera movement, with the associated TT-1A. Now this particular unit is in very good condition, and I have all the associated manuals and documentation that comes with it. The roll chart on this one's in good shape, but I'm trying not to use the roll charts on the tube testers because they do have a finite life. So I am printing some data books. This is one that was available online. This is the 1978 version, which I believe for the TT-1 is the latest tube book. So as you can see, this is pretty thick. There's a lot of tubes in there. So the screws to get into this are actually on the bottom of the case. So I'll have to get those off. I'm going to take the lid off to make getting into this easier. All the knobs look to be in good shape. I believe, from what I was told, there's a problem with this control, with the set line control, but we'll take a look at that. There's also no 83 tube in here. This has silicon rectifiers and a few other things, but the diodes that are in here for the silicon rectifier are known to be problematic as they're aging, so we're going to get those out of there. There's a ton of stuff going on in this tube tester because this particular tube tester tests even better than the previous two that I did. So that Stark and that 15556, they take all the elements of the tube, put it together, and then they do a emissions test, although they do set up some bias and a few other things. This is a very dynamic tester. Or I'm sorry, no. They do set point bias testing of the tubes, whereas this has more elements, so it can handle suppressor grids and a few other things. So really looking forward to getting this tube tester restored and ready for the bench, so then we can test it out. I still need to get some bogey tubes, and there was a question that was asked about why I don't test some tubes with the curve tracers, and the answer to that is it is kind of complicated. You can test tubes with curve tracers, but it's not ideal, and there are things that you can't test. So like a curve tracer is okay for a beam power tube or a triode or something like that, but some of the more complex tubes it would struggle to check. So I'm trying to come up with a solution that is, well, since I'm planning on using SMUs, I can't really say it's budget friendly, but I need to get some very accurately measured tubes so I can just validate the scales and the meters. It doesn't matter what they measure. I just need to know they're measured as accurately as possible that I can do in the lab. So with that, let's pop this out and get the case out of the way. We'll see what rebuild's going to look like. Here is the back side of the unit standing up on the bench. All our screws for getting into getting the chassis out. 6 screws, and it'll just pop out the top. Okay, there's a substantial amount of stuff going on in here. So we got caps all over the place that are going to need to be replaced. This guy needs to go. These need to go. That's a replacement. That's a replacement. These are a replacement. That's a replacement. And that's just on this. That's just on this board. I got some other caps down here that have to go, some here that have to go. We have 2 vacuum tubes that we'll test just to make sure they're not tired. This bathtub can's probably going to have to go. Looking for the rectifier diodes, and I haven't seen them quite yet. Should be discrete diodes in this. There's some more caps that have to go. Let me really give this thing a... there's that line control that we may need to address. I do have nice access to all the switches, so I'll be able to service all the contacts and clean them up. Make them work right. I'd really like to find those diodes. See if I can't locate those. Okay, our first 2 diodes that we need to replace are on the back side of this control. To get to the front side of the diodes, it's actually really easy. You can do it with the control in place. To get to the back side of the diodes, however, with all the wiring, and didn't want to burn the wiring with the soldering iron, it was easier to pull the control out, tilt it up, and then I can get to the back connector of the diodes. So for a replacement diode, maybe enough diodes. We have an entire wheel of 2N39, no, it's 39, 2N4007s. So there's 5,000 parts here. I should have enough for this project. Okay, since we have a wheel of brand new diodes that we haven't actually tested any yet, let's spot check some diodes and make sure we got what we paid for. One of the beauties of having a curve tracer is that makes it kind of easy, because one of the more important parameters we're going to have to set this up for some spicy voltages. But for the first time, we'll do a V forward, and that's 0.1, 0.2, 3, 4, 5, whoop, there we go, starting to turn on, and 0.6 volts. So we get a nice characteristic diode curve. So with these being 1N4007s, they should have about 1,000 volt withstanding. So let's reverse the polarity and really see what it can do. So I have flipped the diode around in the test fixture, and we are going to... What are we going to do? Make it angry and red. So I have it on 1,000 volts now. As you can see, we have lots of warnings. I have defeated the interlock on this, so I do not want to get anywhere near the test fixture while this is going. We're still on DC plus, which is fine, but we're going to flip the collector volts to division to 200 volts. And I want to look for, let's call it, a microamp of leakage through the diode. So let's see what the diode does. Put it in test. Looping compensation. That was just looping capacitance, which is fine. I've kicked it up to 10 microamps. So we'll move this over to the beginning. So we're already at about 150 volts. I'm trying to do this around the camera, and it's being difficult. So that's, what is it? So that's 400 volts across the diode. 6, 8. That's 1,000 volts across the diode. And I don't see much. Let me move this up. Actually. There we go. So we have a nice flat line. Deal with some looping capacitance. Yeah, so we're not really conducting much through the diode, which is fine. Everything is good to go. So these look like genuine parts, at least for the sample of one. So I'm going to go ahead and use these diodes in this restoration. I'm going to make this safe before I do anything else. And then we will, I'm going to just crank it up some more, see what kind of, that's 1200, 1400. Okay, we're just yeah. All right, so 1400 is when we break down. So we have a breakdown voltage of 1400 volts, reverse breakdown on these diodes. Now, since I did set this one to reverse breakdown, I'm not going to use that diode because that could have been damaged. So I'll grab some more off the roll. But, yeah, performing well above specification. Okay, I have this section rebuilt. We have our diode here, and I pulled the heat shrink back a little bit so the diode could vent or could cool and not overheat, being encased in the heat shrink. We have a balancing resistor, this high wattage resistor going across these two capacitors. These two capacitors share a negative at this point here. So we have power coming in, rectification, and then a balance resistor. So this is a bulk DC supply. Not sure what the voltages are on that yet. They had 50 working volts, 100 microfarad, 50 working volts DC. I had some 120 microfarad, 200 volt DC capacitors, so we put it there. I didn't need to worry about bumping up in the capacitance a little bit because we have a silicon rectifier here. We don't have a tube rectifier, so I don't need to worry about inrush current as much. Still a concern, but not a total concern. Getting this section done without melting this wire bundle right here, that was a trick. These contacts are very close to this. This is the main wire bundle coming off the power transformer. Power transformer you can see right back here. So I did not want to do any damage to this wiring at all, which we got done without too much trouble. This is the is this grid or plate? This is the grid cap cable that comes out of this couplet circuit. So to get that out of the way, you just pull it through, and it'll hang in the front and be completely out of the way. One of the really nice things about working on this tube tester that I've realized is, because it was a kit and it was designed to be built by a person, not in an assembly line and gone together once and done. This was designed to be serviced. Doesn't matter how you set it. You can set it up like this. You can set it on its side. You can set it on its back. You can set it on its front. It likes sitting. There's nothing getting crushed. There's nothing. You don't have to worry about breaking anything. The only time you really have to worry is if you set it on its face, so you don't scratch the meter or anything like that. But this is really designed to be serviceable. It has not been bad to work on, other than taking care not to burn some wiring and getting all of this. I completely disassembled this section and rebuilt it. And it still amazes me just the size difference in capacitors from a more vintage cap to a more modern cap. These are 200 volt caps. This is a 50 volt cap, and they're a quarter of the size, half the size. Things are plodding along, or things are progressing as one would expect. I did find some bad components that we are going to have to swap out that power pot. I'll go into more detail about that when I get the parts in. That's already been ordered. I also ordered, I did not have any suitable capacitor replacements for the bathtub cap, so I had to order some in too. One of the critical things about this capacitor is it is rated at 125 volts AC. This is not a DC bulk capacitor. That is a AC capacitor that's in the filament circuit, so it is going to see AC directly off the transformer. There is no rectification in front of it. So even with a shelf full of capacitors at my disposal, I did not have anything that fit the bill in that size. The 3.5, or the 3.6 and 7.1 microfarad in AC. So I guess we will continue. I've got 3 of the 4 diodes replaced already. We've got the 2 diodes that are hiding on the plate switch. We got the diode that's up here that we just rebuilt. I have one more diode I have to change down here, and then that will be the 4 diodes that are in this unit that are known fault points and like to short. So for right now, I'm going to warm up another tube tester. Probably do the, we'll do the Westinghouse. And we're going to check these on the Westinghouse and see if we also need to bring in some tubes. Okay, we're going to set up to test the 12AV6 first. So you'll notice there's no tube in it. We're getting ready first. So 12AV6, we have 12.5. There's no shock. Let's see. JR. Actually, I have to test 3 sections of a 12AV6. So 3. 7. 0. 2. 0. Bias volts are 1.5. And then we want it on low signal 6,000 range. And where's my 12AV7? Is this it? Now the getter looks like it's kind of tired in this one. But we're about to find out. Okay, this should read, oh yeah, test it for shorts. We're good there. And this should read over 800 on the 6,000 volt scale, so around here. That's not great. I was mistaken. I was on the wrong scale. It's reading about 1200. So for the triode section, that is fine. Let's check the 2 diodes that are in here. So we need to go to 0, 6, 02, 0. No bias volts. And we should be on shunt 0. This needs to get set to shunt. But we have a shunt of 0. And we need to get above diode's okay. So diode. Yeah, that one looks all right. And the other one is going to be 502. Same setup. Wow, that's a lot healthier diode than 602. So if we look at the other diode, but then if we look at the pin 5 diode, well, much healthier. So probably okay. We'll see how it goes in the Heathkit likes it, but this 12AV6 is possibly still all right. We'll see how it calibrates. This is a 6A4 tube, so let's test that one too. It is a 3A4 tube, not a 6A4 tube, so okay, with a quick swap of tube testers, we will be able to check this 3A4. So the 3A4, well, knob. Huh. I'll have to tighten that back down. Okay, so the 3A4, yes, this is a 3A4, is identical to the DL93 European tube. Now, I have DL93 data for the Stark, so we're going to use that. So, 2.5. Yeah, DL93. Okay. And then we need to go to DX 8210. 8210. And it's the DL93, not the 94. Bias is 33. English, oh no, bias is 33. Helps if I turn the right control. Jesus. What are we doing? This is 73. We want that to be on the 3000 scale. That's going to be a problem. I may not have a tube socket. Oh no, I do. Yeah, there we go. It fits. Line adjust. We're running way hot today. Tube lighting up. Should be. Testing almost 1500. Falling to about 14. So, it's a little weak. Not bad yet, but a little weak. This is saying my minimum would be 1260, and my average is about 2000. So we should be up here, but minimum's going to be kind of down here. We're about right in the middle. Let's do a life test. Now, what the life test on this tube tester does is it drops the heater voltage by 10% to kind of guess how much life is left in the tube. So I'm going to let the tube cool off for a little bit because we've been hitting it, and run the test again and see at least what the Stark thinks. Okay, that should be enough time for the tube to cool off. Let's see. Right at about 1300. 1400. So it's probably going to be okay. These do, but this ultimately means the way the getter was looking, I kind of assumed that these have some time on them. So we'll see how the calibration goes. Obviously, the best test of a tube is the circuit in which it lives. So if the calibration goes okay, we'll let these ride, because I can always just pull some out of inventory and pop them in if I need them. But if the calibration doesn't go well, the tubes will be the first thing I'll refresh for some new ones. Just doing an interim power-up test after a bunch of work got done. So we're running about 6 watts out of the wall. Here's what kind of happens when the power pot dies. There was a note on this unit, so I knew it was safe to turn on because somebody was using it this way. But what they were saying is if you try to set the line voltage by doing a line test, yes, I'm going to use a pair of pliers, but this pot's getting replaced, or this rheostat's getting replaced. Off. On. So either end, it works, but they were using a variac to do the line test. So I can spin this up, spin it all the way up to the side. and it comes back. But on this side, the line test is way high, and I can bring it into operation with a variac, which I'm adjusting now. I do have this hooked up to the current limited variac supply, so if anything goes dreadfully wrong, there's right in line with the line check, but I'm running at about 108 volts, so not thrilled with the way that's working, but as it sits right now, let's throw a tube on it. I did put the other 2 tubes back in, and at least see if we have meter deflection. Nothing matters yet, and I still haven't rebuilt the bottom side, but we're not drawing a horrible amount of wattage, so let's throw a tube on it and see if we can test something, just to kind of sanity check the unit as we're going through the process. Okay, I have the tester set up for our obligatory 6L6. I think I do. I have to check these switches first. I forgot this one has more switches than I am used to, but we have not actually done any GM testing yet. So, K1, P1, G1 for cathode plate and grid. Line test fell a little bit. Give it some more power. The tester is actually, let me bypass the bulbs. If we're going to do a test, we might as well give it real line. Bouncing around in the meter was the bulbs were dropping some of the line voltage, so it was running a little soft. The line voltage is now running at 109, 110, so we will test the tube for leakage. And we are on this one, since there's no shorts lights, you're looking for meter deflection. So if it deflects at all, that's a bad sign, and testing should stop at that point. We don't have any leakage. Triple check my settings. F 35 high for the bias. 6.3 volts on the filament. 44 on the meter. Signal is 4. 0, 7, 3, 4, 5, 0, 6, 1, 0, 0, and then the other zeros are for the unit that's not attached, the AA portion. And we are good. So we have a 3x, so whatever the meter reads, we need to multiply by 3x to get the correct GM on this one. And we're reading, call it 1900 times 3. 1900 times 3 is about 57, which is really close to where this tube, because it's the same one I used in the other vacuum tube videos, is reading. They were coming in at about 56. So, aside from the set line pot being completely toasted, which I'll show everybody here in a minute when I get the new one in, this was not a cheap part to replace. Oh, I think that's the most I've spent for a potentiometer ever. But it's a 25 watt variable resistor, 350 ohms, and it's not 350 ohms. So it's something happened to this unit and it's completely burned up. So very cool. I still have to service the bottom of the unit. We'll shut it off and get everything going there, because I still have a bunch of caps I have to replace. But for just kind of quick function testing, Very happy with that, and work will continue. Well, bias is wrong a little bit. I shut the tester off and was going to let it sit for a little bit because the other testers, the tubes were relatively cool, and I got burned off of that tube. So that tube was really hot. So definitely need to change those caps in the bottom. Bias is a little bit off, but this has the nice thing about this tube tester is it has a calibration procedure. So we'll go through the calibration procedure after I get the unit rebuilt. But ow. Okay, I've got the two sections rebuilt. I've got the bottom section rebuilt, and it always amazes me the size difference between modern and vintage components. I'm waiting on a 4 microfarad capacitor to go right here. I did not forget it, but we are going to test the tube. I'm going to clip in this 4 microfarad cap, which is what used to hang out right there. And then I've also got this electrolytic replaced, that electrolytic replaced, and this paper cap replaced. I was going after these diodes that were in there, and there is a diode on this switch that needs to be replaced, but somebody had already had to do it once. So we did have somebody's been in here before. I don't know if this is what, if that diode shorting is what took out the power pot that I have to replace. But I have caps ordered. I have a power pot ordered, and we're gonna give this one a new lease on life. I still have to do the bathtub cap right here, but that's also part of the other parts that I had to order because I didn't have anything that was that high a AC rating. So let me get this flipped over. I'll get that cap clipped in, and then I'll hook it up to the current limited supply, and we'll just test that 6L6 just to make sure everything still works. Okay, I'm ready for a smoke test. And it looks like we're drawing about 12 watts out of the power supply. That should drop once the tubes warm up. And we're down to about 10. So let me get that tube, and we'll be back. Okay, I've moved the camera off to the side. I have put our vacuum tube in. Gonna do a line test. You need to tune that up a little bit. A little bit more. Yeah, that's good right there. Okay, so we got our tube warming up. Let's triple check. Where's my data book? Triple check the settings. Found my data book. For the 6L6, I've been testing this 6L6 enough times, I might memorize this by the end of this. We're now drawing 40 watts out of the unit. So with the 6L6 in place, we're drawing substantially more power out of the tube tester. F for plate. .35 high for the bias. .3, which we are at. 44 for the meter. Signal pin is 4. 07 345. 06 1 0. Okay, we are where we need to be. We're on normal. We are not there. We're on grid plate, cathode grid and plate 1. Check for leakage. Oh, we have some screen leakage on that one. Yeah, that might explain why the tube's getting so hot, because it is getting very warm. So I'll check it in my other one for shorts, but this did show up a little bit of screen leakage on that tube, so this might, now this has not been aligned or calibrated yet, and we have replaced a pile of parts. So I can't trust anything it's telling me at the moment, but it is working, and that tube is very warm. So, all right, well, we'll keep going and go from there. Everything is looking okay so far. we may actually have a bad 6L6. I'm testing another 6L6, same settings, same everything. And if I do the grid and screen leakage, we get no response from the meter. So this 6L6 may be damaged. Now, I have this 6L6 marked. This came out of an amp that I repaired, so this is actually a very, very used tube. And I know this was red plated for quite some time, so it would not surprise me if it has internal damage and is dead. So that is not a brand new 6L6. That's a out of the questionable tube box. So the meter may be showing us truth. I just need to get it through a calibration, because right now I don't trust it at all. But this other 6L6, no screen leakage. And let's see. Yeah, line test is good. And we do have a good GM test, so I don't know. Might have found a bad tube that the other ones were passing. Interesting. I will also note that the tube that is behaving is running much cooler than that other 6L6. So I'm starting to think that 6L6 might be struggling. Well, out with the old and in with the new. So this is our new set line pot for this unit. This is a $80 potentiometer, by the way. This is a little bit steep, but it's a 350 ohm, 25 watt potentiometer. Now, the reason the unit was working at the extreme ends, so here's the wiper that controls the potentiometer, and out in the track, out here, it reads about a mega ohm or so. But if you watch right here, it pops over and just dead shorts to either of these sides. So that's why the unit was waking up when this was all the way over, because it could finally get some voltage into the transformer. So this pot is completely dead. We have the new one ready to go in. And also, I didn't realize it when I ordered these caps that they were going to be this, but some of these are Chungus capacitors that have to that I have to fit in here. There's the this is the what? This is the 10. Those are 4.7, but they're so like 10 microfarad at 400 volt. Yeah, 4.7 microfarad at 400 volt. But these are what I need for the AC. So actually what I need to do is I need to shoehorn these three caps up where that big giant bathtub cap is. And then this should be ready for an alignment, I think. That's it. All right, here's our top section after rebuilding the bathtub capacitor that was in there. I didn't even need to test this capacitor to see if it was good or bad. The case is actually bulging, so this cap is definitely toast and is out of there. So if there was any question as to whether this was a necessary rebuild, well, it's toast. One other thing that was interesting was this one was marked common 733, and I looked at the I wanted to confirm with the instruction manual what that was. So I pulled this off. It's 33 common 71. So with the 33 common 71. So this is labeled wrong. The unit was assembled correctly, but it was labeled incorrectly. So glad I checked that out and just made 100% sure everything was right. So, where are we at? Well, I'm going to replace the tubes that are in this unit, because I did test the tubes off camera, and they are very tired. They're still working, but they're tired. And I requested the lab, ask and ye shall receive. So, we have a 12AV6 and a 3A4 that were in the lab, so I had those tubes in stock. I have tested both of these tubes in the other tube tester, and they are fine. So we're going to put those in the tired tube category. I was hoping to do some Amperex for both, but I did not actually have a Amperex 3A4, which means we'll have to go with a new old stock RCA, which is also fine. The tubes we're testing for these on these new tubes, the tubes we're testing about 25 or about 75% of what the new tubes were testing. So we have our 2 fresh tubes in place, and everything is good. Here are the old ones, and as we can see, this getter spot is starting to turn a kind of chocolate brown color. So these 2 tubes and so is this one. These 2 tubes definitely have some age on them. Okay, I'm getting ready to start the calibration procedure on this particular unit. For the calibration procedure, all of the selectors have to be on 0. They are. Leakage should be tube test. Signal is 8. Meter is hard clockwise. Bias is 20 low. Grid current is spring loaded. Plate is A, and filaments at the moment don't matter. We need to turn the unit on, and then we need to do the line test. And I did need to mechanically zero the meter. It was slightly off, not too terrible, but it was off. The camera is off to the side up here, so I'm looking straight on the meter, and the bench is rigid and flat. So we are good there. Also, the calibrate switch, which is down here in the bottom, is set to operate. Now we set the meter to bias. And we're off a little bit, so we need to adjust CD for the meter to be over line check. Easy enough. Get a low capacitance screwdriver for that, just in case. These are potentiometers, so it shouldn't matter too much. Okay. Turn it back to operate. Check line test again. We're still on. Turn it back to bias. We're still on. Okay, so our bias is now good. Bias is maximum counterclockwise. Meter is maximum clockwise. The meter pot needs to be tightened up. It's slipping. That's now tight on 50 and lined up again, and signal needs to go to 1. We again need to check line voltage. We are good. Now we're adjusting signal. And GM test. And we're a little over. So I need to find CG, the control. I think that's on this side of the unit. It is. CG is right here. That control needs a cleaning. It is very noisy. And a bit of cleaning later. Let's see if CG will let us calibrate now. Much nicer. That's dead on. Go back to operate. Line test. Back to signal. Yeah, all right, cool. Next is up is the meter circuit. Plate goes to C. Bias is maximum counterclockwise. Meter is maximum clockwise. They are. Signal is TT-1. Calibrate is to operate. Okay. So what we need to do, and our meter control had slipped, so it's a good thing we're doing this adjustment. Line voltage check. So now we go to meter circuit, GM test, and we want this to read 1100. So 1100 is the first large division. We're close. Right there. To exactly 40. I think that's good enough for government work. Let's test the line again. Looks good. Test the meter circuit, full on. GM test, 1100. 40, 600. That is perfect, dead on. So we are good to go, and everything is good. This is actually calibrated and aligned. I love units that give you the schematic. So, for now, this needs to go back in the case. All right. When putting one of these back in the case, make sure you actually set the switch back to operate. Not that you leave it in the meter calibration position, so it doesn't work. One thing that did happen to this unit was the knobs that were on these two slid off as I was putting the unit back in. The bakelite was so, I guess they had some springy material in there that it should spring out of the way to kind of just hold them on. Well, it's so brittle, pushing them back on just shattered the inside of the knob. So I will have to find some switch covers for these. Not too big a deal. If anything, I'll 3D print some. I'll 3D print some switch covers, and we can make them be whatever we want. So that won't be a problem. But now that we have a fully operational tube tester, let's check this Bunk 6L6 again and see what it says. Okay, I've got the tube tester set up. I've got the tube in. We did see a huge reduction in line voltage when the tube fired up and started drawing power. Now I'm also drawing 34 watts out of the tester, which is a little much. So let's check for leakage. And remember, any deflection in the meter, bad tube. Grid is good. Screen is good. Plate is good. Suppressor is good. Heater and cathode is good. Okay, so let's see. Reading should be above 1300, but then we need to multiply by 3. Oh, very healthy tube. That's reading about 6,000. So I don't know what it saw before, and that could have been halfway through the reinstall, or the repair, when it saw that leakage. Yep, well over 2,000. So very healthy tube, and very healthy tube checker. So very happy about that. Well, thanks for stopping by the lab and taking a look at the rebuild of this Heathkit mutual conductance tube tester, the model TT-1 with its associated TT-1A top hat. The dish of shame is quite full in this tube tester. Lots of stuff was going on here. Significant amount of capacitors needed to be replaced. Some diodes needed to be replaced. Mine had a burned out pot. So that wasn't. This is now fixed and everything's ready to go. So I've been getting a lot of questions about the tools and supplies that I use around the lab. In the description of the video, it will point you to my website, which will take you to a page with a bunch of Amazon affiliate links for checking out some of those. That page is in process and is will be forever updated with things added and removed. So if that's of interest, check that out. As always, thanks for stopping by. And again, thank you to all the patrons that help keep the lights on. More is always on the way, and I will see everybody in the next video.